Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will learn two interesting things of observability. One, hybrid cloud infrastructure monitoring. Two, anomaly detection using AIOPS. To learn these concepts, we will use an enterprise observability platform, and this tutorial is going to be both theoretical as well as practical. We will use Google Cloud Platform and on-premises Kubernetes cluster to learn about hybrid cloud infrastructure monitoring. So make sure you watch this video till the end. Let's get started. So before we jump into the demonstration, it's worth understanding few concepts. Starting with what is observability and why is it critical for the organizations. Then what is hybrid cloud infrastructure monitoring? Finally, what is AIOPS and how is AIOPS shaping the space of observability? First, we will understand these concepts theoretically. Then we will learn how companies can implement them practically at the enterprise level. So let's start with understanding what is observability. So for any organization, irrespective of the domain, it's important to have their application available and reliable at the same time. That means application is running 24/7 and the running application meets the expectations of the customer. Every company signs a service level agreement with a service level objectives with their customer. So the running application should meet the SLOs. Now you might say, Abhishek, what is the point? Because our company has a very good production support team where if the application goes wrong, assume application went down because application is running on a virtual machine and virtual machine ran out of memory. Now we have a production support team which gets in touch with the customer, explain the situation to the customer and unblocks them in 3 to 4 hours. Now this is good because the customer is unblocked. But what if you run into same issue again? Or maybe you run into different issue, but that creates another 3 to 4 downtime, hours of downtime for the customer. Now this creates a very bad user experience for the customer. And if this downtime occurs during busy or peak hours of customer, that will also incur a business loss for the customer. So having a production support team to unblock the customers is good, but it's important to prevent such issues. So for that, every company needs a feedback system where the feedback system continuously reports internal state of the system. So in this case, if you take this example, the feedback system, which can be set of tools, should monitor the memory of the virtual machine. Let's say the memory of the virtual machine reach 80%. Then this feedback system should send an alert back to the DevOps or SRE team stating, hey, currently I see that the memory of the virtual machine is 80%. Before it reaches 100%, please take an action. Not only memory, it can be CPU, it can be disk utilization, it can be anything related to your application as well. At broad level, this feedback system can work at the infrastructure level and also application level. Infrastructure level, just like things I explained, it can be issues with the CPU, where if the CPU reaches 80%, the feedback system can send you an alert, or disk utilization, memory, anything related to infrastructure, or it can be related application as well. Let's say your application, which is inside a virtual machine, responded back with 502 gateway. And if it happens once in 100 requests or once in 1000 requests, it's okay. But imagine your application response is 502 10 times out of 1000 requests. Then this feedback system should respond back with an alert to the DevOps or SRE team that out of 10 times, we are currently noticing, sorry, out of 1000 times, currently we are seeing 10502 bad gateway issues. So please take an action. So this feedback system related to infrastructure or related to application is called as observability. Now, observability works on three primary pillars. Pillar one is metrics. So metrics is nothing but historical data. So it can be historical data of your CPU, disk, or memory, or anything related to your application as well. The second pillar is logs. Similarly, your application logs or infrastructure logs, because logs provide a lot of information. In this case, why 502 or why 404, why 500 internal server error. You can get that information from logs. So metrics, logs, and traces are important pillars, three important pillars of your observability. Using these things, your feedback system works, and your feedback system sends an alert to your DevOps or SRE team. So, in a nutshell, observability is a feedback system that works on metrics, logs, and traces. Using this information, observability can send an alert to your DevOps team or SRE team to avoid future issues, right? Or to tell them to please act on the issue. Now, if you want to get detailed information about observability, if you want to learn it right from zero, we have observability zero to hero playlist. I'll put the link in the description. You can watch that. Now, Abhishek, you mentioned that observability can be related to infrastructure, and you provided example as well. But why do you need it at hybrid cloud level? There are two main reasons why hybrid cloud infrastructure monitoring is important. One, today companies prefer multi-cloud setup. Companies might have their application running on AWS, their database running on Azure or storage on Azure, and Kubernetes clusters on GCP. Now, how do you tackle this situation? Of course, every cloud provider knows the importance of observability. So AWS has a observability stack, Azure has observability stack, GCP also has observability stack. But you cannot set up three different observability stacks for your application. Instead, you can go for observability stack like Manage Engine, which I'm going to demonstrate, so that you can have your entire observability setup with manage engine provided by Site 24 by 7, or you can use a common observability stack. Another important thing is, right now you might be with AWS, but tomorrow your organization decides to move to Azure. Moving your application is not that difficult, but moving your observability stack is difficult if you lock with a particular vendor. So if you use observability stack of AWS, moving the observability stack to Azure is a lot of work for your organization. So to avoid such thing, to avoid vendor locking, another reason is to use a common observability stack that is cloud agnostic. Okay, Abhishek, this is clear. And you also told me that you're going to show how to set up multi-cloud or hybrid cloud infrastructure monitoring. Now, what is AIOPS? So AIOPS stands for AI for IT operations. So this is typically in the space of observability, where by now you might have understood when you are dealing with observability, you are dealing with huge amount of data because you are dealing with metrics, you are dealing with logs, and you are dealing with traces. So it's huge amount of data that's coming to your observability stack, right? And your observability stack process this huge amount of data and provides you with any action items. We all know how AI can perform when data is involved. So your observability stack currently, it can tell you that your memory utilization is 80%. Please take an action. But when you involve AI in the observability setup, what AI can do is, if you take metrics, for example, it can look at the historical data. Maybe on 1st of March, the CPU utilization was 10%. 2nd of March, the CPU utilization was 10% itself. On 3rd of March, because of some issue, the CPU utilization shoot up to 60%. Then on 4th of March, the CPU utilization shoot to 70%. And again, it came back to 10%. After 1 week, again, the sudden spike in the CPU utilization went to 70%. Now, you have set up an alert in your observability stack to only report when the CPU utilization is 80%. But here, there is a strange pattern. And this strange pattern might take your CPU utilization instantly to 100. That means by the time you get an alert, the CPU utilization might instantly jump from 80% to 100%. So even though you got the notification from your observability stack, by the time you log into your system, try to identify the issue, it reaches 100%. So a downtime is created for your application. If you have AI ops setup, that is AI setup for your IT operations, it can predict this pattern. So it can look at this pattern and it can predict that looking at the pattern, maybe in 1 month from now, your application can go down because the pattern looks like that. Or because of the AI algorithms, it can predict that maybe on 17th of March, your application can go down, right? So this particular thing where AI can perform the prediction depending upon the data is called as AIOps. So what AIOps can do for you? It can do three important things. One, it can analyze the data that is provided. Two, it can anticipate any future issues. That is, it can predict anything that might happen. Three, it can help you avoid such situations. So AIOps can analyze through your data, it can anticipate anything that might happen in the future, and it can avoid. Especially this is the power of AIOps, or this is the main factor of AIOps, where it can anticipate that a human cannot anticipate. For example, you have seen the climatical conditions of your locality for the last 20 years, 25 years. But when it comes to weather prediction apps, they are better. Why? Because weather prediction apps work on AI. They collect historical data of the climate of your locality, and they try to predict what can be the temperature of a place on 17th of March, which a human might not do. Or even when you talk about observability, there are hundreds of applications, hundreds of services, there are hundreds of metrics. So as a human, you cannot go and look at each and every metric, which AI can do. So this is about observability, hybrid cloud infrastructure monitoring, and AIOPS. Now you might have understood why it is important to set up hybrid cloud infrastructure monitoring, or at least be cloud agnostic and not to get into vendor locking with your observability stack. And second, you might have realized the importance of AI ops. So let's see how to implement these things. For this, we will use Site 24 by 7 by Manage Engine. I created a free account with the platform. You can also create one using the link in the description or pinned comment. As I told you, it's an end-to-end observability platform where you can set up monitors. It supports different kinds of monitors, which we will be looking at. You can create dashboards for your monitors. You can use it for log analysis and log aggregation. You can use it for application performance monitoring and also anomaly detection or AIOPS. You might ask here, Abhishek, how do I actually decide upon an observability platform? I would recommend a couple of things. One, look at the ease of use of the platform according to your use case. Second, look how efficient is the platform according to your use case. Today we are dealing with hybrid cloud infrastructure monitoring and AIOps. Site 24 by 7 is pretty easy to use and it's super efficient when it comes to both of these use cases. That's why we will use Site 24 by 7 in today's demonstration. We will start with setting up monitor for GCP virtual machine. So on my Google Cloud platform, I have already created a virtual machine. So if we go to Compute Engine and if we select virtual instances, so here I have the virtual machine. We will first set up monitor for this, and then we will use our on-premises, that is local machine, to spin up a Kubernetes cluster and also set up monitor for that. First, we'll go to this instance and we will use Cloud Shell. If you want, you can use a virtual machine from AWS, Azure, and connect that to your terminal as well. So how do I set up monitor? Just go back to the platform, click on monitors and click on this plus icon where they already have steps for different monitors that you can create. Let's say you want to monitor a website, or maybe you want to monitor a REST API, or you want to monitor a virtual machine, which we are going to do, or maybe a Docker container or Kubernetes cluster. They have steps available for all of the different monitors. So I'll just go to servers and click Linux server monitoring. So these are the steps I should run. Just two steps. Start with the wget command to download the script. Okay. And then execute the downloaded script. So again, I'll copy the command. Because this is Cloud Shell, I should use sudo followed by the command. So you can see here, it is installing the agent. Once the agent is installed, just wait for a couple of minutes. In some cases, it might take less time, but agent has to communicate with the platform and it has to push all of the metrics to the platform. So you just need to wait for it. Okay, so while the agent is installing, just make sure to read the logs. In case of any error, you can identify and you can reinstall. Overall, it should return a process ID and that tells you that the agent is up and running. So this is the process ID and the agent is running right now. Let's go back to the monitors. And I already have few monitors set up, but what I'll do is I'll just check for the server monitor. Perfect. So the server monitor is set up just by running those two commands. So here it says, if you want to set up thresholds, there is a shortcut. However, right now, I'm not interested in thresholds. First, I want to see if it got the entire information. Okay, it's still fetching the details. Let's refresh. Perfect. So on our Linux virtual machine, on the GCP platform, it says 26% of CPU utilized, memory, disk space. I can also go to these tabs for detailed historical information. As per the timestamps, what is the CPU utilization, what is the memory utilization, disk space, and also network related metrics. You can also see the summary of the overall metrics or the state of the virtual machine. So it's that simple to set up. Now let's see the same thing for a Kubernetes cluster. And to make it complicated, we will use on-premise Kubernetes cluster. Kind create cluster hyphen name. Let's just call it as hybrid cloud demo. Hybrid cloud demo. Because it's kind, it creates the cluster very fast. So we should have it in next couple of minutes. And once we have it, perfect, the cluster is up. Again, we will go back to monitors, click on the plus icon, and let's go to containerization, that is Kubernetes. So it provides you steps using the plain manifest, steps using Helm chart, sidecar container, GKE, and also OpenShift using OC client. I will use Helm, which is a popular choice. First, I'll check if I have Helm installed, Helm version. Okay, so I have Helm installed. Also, I can just check kubectl config current cluster because I have multiple Kubernetes clusters. Kubectl config current context. Okay, hybrid cloud demo, the one that we just created. So then we can install the Helm repo. I mean, we can just add the Helm repo. Okay, I already have it. It's best practice to update the repo. Once the repo is updated, we can proceed with the secret creation for the agent. So what Site 24/7 or Manage Engine is doing is it is creating agent. When we were using virtual machine, a agent was created. We downloaded the script, and once we triggered the script, a agent is created, and you can see agent is running on this process ID. Similarly, when we choose a Kubernetes cluster, it is trying to install the agent using Helm chart. Okay, the secret is also created. Now, if I run this command, we should have the agent running. Let's just provide release name. I'll call it manage engine demo. Perfect. So the Helm chart is executed successfully, but make sure the pod is running. So this is the agent, and right now the agent is not in the running state. So we will just wait for the agent to move to running state, and only then we will go back to the screen here and look at the monitors. Okay, so the agent is in running state. Still, it's good to wait for a couple of minutes because I have other Kubernetes clusters. We can just go to K8 tab here and we can see different Kubernetes clusters that are here assigned to the platform. So this is the one hybrid cloud demo control plane, and it fetched the complete metrics related to the Kubernetes cluster. Just like how we set up infrastructure monitoring for virtual machine, we also set up for Kubernetes cluster. So it says there is one node, 11 pods, 3 services, and you can find infrastructure related metrics. So what is the memory? What is CPU? If you want historical data, you can also get that using the graphs. It also fetched Kubernetes events, which are great thing to debug Kubernetes cluster and understand the state. So overall, we learned how to set up monitoring for a virtual machine and also Kubernetes cluster in less than 5 minutes. Now let's see how this platform can be used with AIOPS. If you remember the theoretical part, I mentioned to deal with AIOPS, you need historical data, because only when you have historical data, just like the weather reporting application or the climate application, it can tell you the climate of a place, or it can predict the temperature depending upon the historical data. But right now, we don't have historical data. We just added Kubernetes clusters and virtual machine. Now, how can we use it? Don't worry, Manage Engine Site 24/7 provides a demo cluster. So they have a playground environment. I'll also put that link in the description. And this playground environment is available for everyone. You can get a read-only access to the platform. And if you go to Zia Anomaly Dashboard, very simple, just go to the home page, look for Zia Anomaly Dashboard. On our account, you will not find any anomalies because we don't have historical data. But if you go to the playground environment, you can see a lot of anomalies are identified. This is because this environment is set up with huge number of monitors. So there are almost 1200 monitors, because of which the anomaly dashboard or AOP solution has a lot of data to deal with. Okay, so we can see that there are 11 confirmed anomalies here, and we can see when it comes to a REST API that is monitoring, there is one confirmed anomaly. Similarly, if we just scroll down, you will find more number of anomalies when a huge amount of data is provided. Here we can see when it comes to cloud monitors, there are 38 identified anomalies. And if we just click on that, so it will also provide the anomaly history. That means if you read this, it says the disk writes has surged to this number of bytes per second. This has resulted in 2.1 times increase in the disk write. And if it continues, so what is it trying to explain? That there is a surge in the disk write, and if it continues, the platform might go down, because if there is no disk space, definitely the application won't perform. And because of that, the application might go down. So here it identified the anomaly. That's why it provided with a red symbol. If you want, you can also take action for this anomaly, or you can just use this platform to look at the anomaly or send an email or a Slack notification. Similarly, if you scroll down, here it says MySQL has 11 confirmed anomalies. So there is anomaly that is detected with respect to the database. And there is a server monitoring group. Again, it says there is anomaly that is identified. It also identified anomaly on a particular website. So if you go here, this is not infrastructure related anomaly, but here this is related to the response time from the application. So usually these are some things that go unnoticed, because unless your application response time is very slow, you will not notice this. For example, if you assume that your application usual response time is 2 seconds, just for example, and if application returns response in 2.1 seconds, you will not notice it. You will just think it is because of latency of your system or some issue with your internet. And even if it goes to 2.2 seconds, you might not worry a lot. You will not start debugging your application. But with Zia Anomaly Dashboard or with AIOPS solution here, it tells you that there is a surge with milliseconds time, and this surge occurs at a particular timestamp. Here it also says I am noticing it from 6 a.m. to 7 a.m. in the morning for the past 4 weeks from a particular geography. See how detailed information that it provides. It tells you what is the surge in the milliseconds of time of the response time. It tells you the particular timestamp. It tells you the period. It also tells you from which geography is this issue occurring. So using which, again, it makes things easy for you to go back and fix your application. So I would recommend you to go through multiple anomalies that are present here. So if you just go to the monitor section, you can find 47 confirmed anomalies. So I hope you enjoyed the tutorial about hybrid cloud infrastructure monitoring and also anomaly detection. Perfect. Just a couple of things before we conclude this video. One, Manage Engine also supports on-premises version, which is called Manage Engine ITOM. So if you're interested in on-premises version, you can definitely give it a try. Apart from that, the most exciting part is that for our subscribers of the channel, Manage Engine is offering 6 months of free trial on their cloud version, which is Site 24/7. So you can use the link in the description and avail 6 months of free trial. This is only for our subscribers, and if you use the link in the description. Thank you so much for watching today's video. Take care. See you all. Bye bye.